Hey everyone, I hope all of you are having a great day. So just wanted to make a quick video related to the strategy for organic chemistry. I could have made like physical and inorganic and organic in one video, but it just would become really long. So I decided that I'll just divide it into three videos. So right now I'll be talking about organic chemistry. So I've done the analysis of last 8 exams just to give you a quick overview. That is the June 2018 exam, December 2018. Then we had June 2019. In December 2019, we had two examinations due to floods in Assam. So the exam for Assam was different. Then in June 2020 also we had two examinations. One was in Tamil Nadu separately because of the cyclone, and then in June 2021 we had one examination. Okay, which was actually conducted in February of 2022, that is this year. So in fact in 2021 we did not have any examination, but this June 21 examination was extended to Feb 20. So these are the last 8 examinations that I've analyzed. Okay, now, what I found was that the last two examinations were comparatively more conceptual than the rest of the questions, the rest of the exams, and probably because COVID gave more time to the the paper setters. So, what I believe is that they uh, they had some articles from research journals. Like I remember there was a question on select fluor. Now select fluor is a very useful reagent. It is one of the only reagents that I actually know of which leads to electrophilic fluorine. Okay, so you know that fluorine is highly electronegative, and most of the reagents are basically F minus donors, but select fluor is one of the reagents which donates F positive, if you can think of it that way. So there were a lot of research-based questions and a lot of conceptual questions in the last two examinations. That is the June 2020 and the June 2021. So I'm assuming that was because of COVID, but we'll have to see that if such conceptual and research-based questions are asked in the future as well, and that is what I expect as well. Okay. Then we have then I'll basically be talking about the must-do topics that you definitely have to do, and then some new topics that you really need to focus on. And when you're preparing for the examination, from what perspective do you look at reagents, do you look at reactions, that how the examiner could frame the question from that particular topic. That is something that I'm going to talk about in this video. Also, if you have any queries, okay, and you want to ask those to me live, so it's going to be a live class on Thursday, that is from 9 to 11 p.m. And to join that free class you have to use the code SETHI. Okay, it's a free class, but you need to enter this code, and the link to the class is in the description box. So if you want to ask your questions live, Thursday 9 to 11 p.m, this coming Thursday. Okay. Anyway, so this is the summary of the questions that have been asked in the last 8 exams, which will basically help you, I can say, concise your preparation. So if you're someone who does not really know where to start off because the examination is in the last 2 months, I think this strategy might be really helpful to you. You can follow your own strategy as well. Just I want to put this disclaimer out there. So if I talk about general organic chemistry, you really need to uh, focus on this aspect: general organic chemistry and reaction mechanism. So in general organic chemistry, if I talk about simple things, acidity, basicity of different groups, or pK. Okay, these kind of questions are definitely asked. You cannot afford to miss this out. Then acid-base catalyzed cyclizations. Okay, this is also one. This you could also categorize in reaction mechanism, but these are very frequently asked. Okay, so if you can practice some questions based on acid and base cyclizations, that will be really good. TCP KCP means thermodynamically controlled product and kinetically controlled product. So questions related to, let's say, in some cases 1,2 addition will happen, in some cases 1,4 addition will happen. So what conditions will lead to 1,2 addition, what conditions will lead to 1,4 addition? For example, if I talk about sodium cyanide, okay, so cyanation, when the Cn minus attacks, okay, so at low temperatures it leads to 1,2 addition, but at high temperatures it leads to 1,4 addition, and such questions have been asked in the examination. Then aromaticity, that's something basic. Generally questions directly related to aromaticity are not asked, but aromaticity, in combination with spectroscopy is sometimes asked. Then I've written over here NGP. This is very very important. You just cannot afford to miss it out. Okay, neighboring group participation. So this is a concept in GOC. There are multiple concepts within it. For example, dancing resonance and a lot of other concepts. So either you can follow my plus classes on Unacademy for NGP, or you could maybe go to this book, that is Jerry and March. Over there are a lot of examples of neighboring group participation. Then we have nucleophilic substitution. Now you might think that okay, nucleophilic substitution is very easy. SN1, SN2 reactions, nucleophilic aromatic substitution, SNI. Okay, these concepts are quite straightforward. But generally, these nucleophilic substitution reactions are as disguised as solvolysis, for example, or for example as decarboxylation or reaction with NAI. So there will be four reagents or four reactants given to you, and they will ask you that okay, arrange them according to the rate of decarboxylation. Or they might give you four reagents and they will ask what will be the rate of reaction with sodium iodide. So that will be based on SN2 reaction. Then solvolysis is basically the stability of the carbocation. So it's sort of like a SN1, you can say, sort of like an SN1 reaction where the solvent acts as a nucleophile. Okay, so when I write nucleophilic substitution, these all things come into the picture. Now, for example, elimination reaction, you might think it's a very simple concept, but then if you can combine elimination in cyclohexane, for example, that means you have to then draw the chair conformation. So that is how they can combine two concepts and increase the complexity of the question. All right. Then we have reactivity of carbonyl carbons. This is also something very important, not just from a GOC point of view, but in general for a lot of reactions also. So you need to know what is the reactivity of different carbonyl carbons, like in different functional groups. For example, what will be the reactivity when you compare, let's say, ester, anhydride, ketone, and aldehyde. Okay, these things are something that you need to keep in mind. Then this one that I have highlighted in bold, these have recently been, like, the lot of questions have been recently put up from these two topics, that is kinetic isotopic effect. Okay, KIE. I have a video on this on YouTube, kinetic isotopic effect, and then Hammett equation. Again, this is also something that I have already made a video on. So these videos were made a long time back, and then after that the questions started coming in the examination. So I'm a little proud of that. Okay, so Hammett and kinetic isotopic effect. These are some things that you need to keep in mind from a general organic chemistry point of view. Then if you talk about stereochemistry, again, one topic that you cannot really afford to miss out. In fact, all these topics, apart from the miscellaneous topic, all these topics are something that you really need to focus on, and you need to at least do this bit when you're going for the examination. All right. So for stereochemistry, we have enantiomeric excess, RNS configuration of different kinds of systems like biaryls, pyrocyclics, and then topicity, like whether the protons are enantiotopic or whether faces are enantiotopic or distereotopic. Then you need to know the basic understanding of Decalin and cyclohexane systems. That which Decalin is simple, uh, like sorry, which is more stable. What kind of you can say interactions are seen in Decalin system. Then what kind of groups occupy axial position, what kind of groups occupy equatorial position. So definitely you have to really do your you need to have a very good understanding of your Decalin and cyclohexane systems. Then type of chirality, these questions are also asked, whether there is helical chirality or there is a chiral axis of symmetry, chiral axis, or whether there's a plane of symmetry. Okay, those kind of questions. Then there are some questions related to sugars, like for example, they can ask you that in the sugar molecule how many stereoisomers might be possible, or they could give you two compounds and they could ask you the relationship between two compounds, whether they are diastereomers, enantiomers, those kind of questions. Then recently in the last exam, there was a question wherein a molecule was given and you had to correctly predict the Newman projection. So that was a very different sort of question. Okay, that how do you convert in a molecule that is given to you into Newman projection. So that was something new. Okay, not difficult, but like I said, something new. Then spectroscopy is like a very vital part. In fact, all of these things that I'm discussing, you have to do it. You cannot afford to miss out. In spectroscopy, particularly proton NMR and 13C have been asked a lot. The questions can range from structural elucidation, that means some data is given to you and then four structures are given in the options and you need to predict the correct structure. That is one sort of question. The second sort of question is how many number of signals will be there. You have to basically find out how many different number of protons are there, or how many different numbers of carbon atoms are there. And then DEPT has not been asked from a long time, so I've just written down over here. You can see some question from DEPT very soon. Okay. Then we have mass spectrometry. In mass spectrometry, just focus on a couple of concepts. One is isotopic substitution, and then there is McLaughlin rearrangement. So if you can focus on that aspect, that will be great. Uh, I've highlighted in bold over here IR stretching frequency for carbonyl compounds, or CO stretching. Okay, and the reason is that this is a very common question, but in the last examination it was not asked. So I'm highly confident that this year this question will be there from stretching frequency of carbonyl compounds. And this spectroscopy is generally complexed or combined with stereochemistry. Okay, it's generally jumbled with stereochemistry. Now the next thing that we have is pericyclic. Lot of weightage in the last 2 years has been seen from pericyclic chemistry, particularly electrocyclic reactions. Okay, electrocyclic ring opening and closing. Stereochemistry over here is very important. Cycloaddition reactions. You need to do Dields Alder in and out. I mean, so many different kinds of questions have been asked over the years from Dields Alder reaction. What could be the reactivity of dienes? What could be the reactivity of dienophile? Okay, so those sort of questions. Then 2 plus 2 cycloadditions. In sigmatropic, particularly focus on 3,3 and 2,3 sigmatropic reaction. Then alderine is also one very important pericyclic reaction. Johnson-Claisen rearrangement is actually a very frequently asked question in the exam, particularly if you see orthoester. Okay, so if you don't know what's an orthoester, you can just Google the structure. So if you see an orthoester in a question in CSR examination, you can be very sure that it will be related to a Johnson-Claisen rearrangement. Okay, because whatever questions in the last 8 examinations that I analyzed had orthoester, they were mostly your pericyclic reactions. And then sometimes there is a question wherein they might ask you, okay, this reaction is happening. So what will be the structure of the highest occupied molecular orbital or the lowest unoccupied molecular orbital? If I talk about reagents now, reagents can be numerous. Okay, and if you're someone who is like preparing organic chemistry in and out, then I mean, there are endless amount of reagents you can keep doing, and still you might find a reagent in the examination that you might not have studied. So over there you need to you know you need to make a decision that whether you really want to go for that question or not, and whether you can attempt it by your concepts that you've built through reaction mechanism. So that is something, that is a spontaneous decision that you need to take in the exam if you have not done the reagent. But the over here I've just listed down some very common reagents that are asked. So one is ozonolysis. Okay, then your LDA is a very common reagent that is seen in the exam. Organolithiums in particular, like phenyl lithium, butyl lithium. So if you come across these reagents, try and do as many reactions as possible, because organolithiums are very popular amongst like examiners in CSR exam. Then your Lindlar catalyst, then your H2 in palladium carbon. Okay, then we have chemoselective reducing and oxidizing agents like sodium cyanoborohydride, Luce reduction, dibutyl, MnO2, which basically does chemoselective oxidations of uh, your what do you call alcohols, right? Allylic and benzylic alcohols. Then your DDQ Gilman reagent, which is basically responsible your like basically reagents which can compete between 1,2 and 1,4 addition. Like I gave you an example of sodium cyanide. Then epoxidations can be carried out by different reagents like H2O2 in basic conditions. Then we have your what else, MCPBA, right? uh, then Grubbs catalyst, and then if you talk about very straightforward reagents like lithium aluminum hydride. Now you might think that why should I do lithium aluminum hydride, or what's important? It's very simple, but you will see in the examination the examiners have literally squeezed out all reactions of lithium aluminum hydride. So forget about its reactions with carbonyl compounds. It can also react with propargylic alcohols, basically an alkyne and next to the alkyne, if there's an alcohol, it's called a propargylic alcohol. So lithium aluminum hydrides do not really react with alkyne, but they can react with propargylic alcohols. That is an alkyne which is next to an alcohol. And then your Birch reduction is also very important. And then they have also shown like lithium aluminum hydrides reaction with epoxide. So if you are doing certain reagents over here, like which the ones is, but especially the ones that I've mentioned, then you need to actually do each and every reaction that those reagents can show. So if you are doing 10 reagents, okay, that is up to you which reagents you want to do. But if you're doing 10 reagents, you should know each and every reaction of those reagents. Okay, you cannot just do a few reactions and then leave it out. And particularly, like I said, focus on oxidizing and reducing reagents. There are endless amount of reagents, okay, but if you are picking 15 or 20 out of them, you should know each and every reaction of those, right? Now coming to reactions, so instead of doing name reactions as such, I'll just give you an example of what all are the most common kind of reactions that are asked in the exam. So coupling is something which is which has a very high synthetic utility in research also. That is why you see so many questions based on couplings. Okay, particularly palladium catalyzed reactions. So the most common ones that are asked in the exam are Heck, Suzuki, and Suji-Drost. And when I talk about Suzuki reaction, one of the common ways to combine or to increase the complexity of this question is to first ask you a question on hydroboration. So for Suzuki reaction, you need a organoboron. Okay, so first step would be synthesis of organoboron, and then the second step would be Suzuki coupling. So that is how they can ask you questions. Then Sharpless epoxidation. Then you need to focus on olefinations. Olefinations are very important from exam point of view. For example, Wittig, Julia, Tebe, Peterson, Takai. These are some of the olefinations that I have listed down, which have been asked before. Then rearrangement reaction like Favorsky, Pummerer, Pine rearrangement, pinacol, pinacolone, benzoic acid. Sorry for the wrong spelling. Benzoic acid, Beckmann rearrangement. Okay, there are a lot of rearrangement reactions. So again, focus. So what I'm telling you is this is not limited to these rearrangement reactions that I've listed down, but you need to focus on rearrangements, coupling reactions, and olefinations because these are very commonly asked in the exam. Then carbines, particularly in carbines, there are some reactions that you need to focus on, like Riemer, Tiemann, Simmons, Smith. Then what are the different ways of generation of carbene? And one common thing that you will see in the exam is that once a carbene is generated, generally they will ask you questions related to the cyclization of carbene. So there you should be aware of how the cyclization will take place and what kind of ring would be formed, whether a 5-membered ring will be formed, or 6-membered will be formed, or 7-membered will be formed. So how to decide that once a carbene is formed, where will it undergo cyclization? That is very, very important. Then benzyne chemistry, just a little bit of benzyne chemistry. Birch reduction is very, very important. It is frequently seen in the examination. And then cyclization reactions. For example, Nazarov, Robinson annulation. This is very, very commonly asked in the exam. I have not listed down very simple reactions like Michael addition or aldol condensation. That is something I'm assuming that you will be already aware of. Then we have managed reaction, Korey-Chaykovsky reaction, that is sulfur yellets, very commonly asked in the exam. Then silane oxide, sulfur oxide elimination reactions, Shapiro reaction, and particularly again I have highlighted over here silicon chemistry. Over the past 3-4 years, I have seen an increase in the number of questions that are asked from silicon chemistry. So I think there's a chapter in Claydon. You can thoroughly go through that as well. Okay, now coming back to reaction mechanism. So most of the questions on reaction mechanism are quite varied. They are very different, but still there are some common features in those reactions. Uh, uh, One of them is that there would be a lot of questions related to reactivity of aryl compounds, okay, or heterocyclics. They are generally given with Lewis acids, so like a Friedel-Crafts reaction will be given. So there you need to know, okay, if there are, let's say, different substitutions on the phenyl ring, then where will the electrophile attack or where will the nucleophile attack? Okay, that is one sort of a question. Then, like for example, if a heterocyclic compound is given, let's say furan is given or pyrrole is given, and they will do the nitration, then you need to know at which position the nitration will occur. Or let's say they will first do acylation and then they will do nitration. So you need to identify where will the acylation occur first, and then where will the nitration occur, whether it will occur at the second position or the third position. Okay, so like that, for heterocyclic compounds and for aryl compounds, you need to know the reactivity. Okay, that where the electrophile will go, where the nucleophile is going to go. Then a lot of questions are asked from nucleophilic aromatic substitution. So you should know the mechanism of how actually the nucleophilic aromatic substitution operates. Very commonly asked in the exam. Then formylation reaction like the Wilsmer-Huck. Again, that depends if you know the reactivity of various heterocyclics and aryl compounds. That which is the most nucleophilic position in a phenyl ring when there are different kinds of substituents present. Then protecting deprotecting groups, particularly BOC, FMOC, diethines, benzyl, paramethoxybenzyl, acetyl. Okay, so what is in what conditions do they get deprotected, and when they are getting protected, which is favored? Okay, like if I have a diethine molecule, then which particular functional group will get protected first? Whether it is going to be, let's say, an aldehyde, or whether it's going to be a ketone, or when I'm doing acetyl protection, then which group will be favored? Okay, if there are three different carbonyl compounds, then which will undergo protection? Okay, the reactivity of these protecting deprotecting groups. And again, I mentioned over here organolithiums, because in reaction mechanism questions, a lot of questions related to organolithiums, and they cannot be classified into a reaction as such, like into a name reaction. They are just based on reaction mechanisms. um, okay, so these are some of the things that you definitely need to do, which is like I said, uh, frequently seen in the examination. And if I talk about miscellaneous topics which you can decide to do if you want to, photochemistry, again, I'm not photochemistry. See, there are a lot of questions from photochemistry, but I'm not listed down because the questions can be very different. So sometimes the question is from Norrish 1 type 1, Norrish type 2, or dipymethane rearrangement, but then sometimes the questions are completely different and asked from research articles. So that is something that you really cannot attempt to do. So that's why I've written down photochem over here. Actually, I've written it down twice. Then your Edmund degradation Sanger method isoelectronic point, if you want to do peptides. Sometimes these questions are asked, sometimes they aren't. Okay, it's not very common. Then structure of DNA RNA bases. If you want to do carbohydrate chemistry, focus more on glucose reactions. They are commonly seen. Then there are some questions from natural products. For example, classification of terpenes, steroids, flavonoids. A compound will be given to you and they will ask you, okay, what is it? Whether it's a terpene, whether it's a steroid or a flavonoid. Then this is something that has asked only once, but I think the number of questions from green chemistry will particularly increase. The question that was asked was in, I think, 2020 June 2020 exam, that was related to the atom economy. Okay, then your radical reactions, and yeah, if you have time, synthetic routes to common heterocyclics, like Fisher and Dole synthesis, or what are the common routes to synthesize quinoline like compounds. Okay, so I think this is a broad overview of the topics that you can prepare. How you need to prepare in the last 2 months is something that you need to decide, that what kind of topics, or what sections you are strong at. So let's say if you're strong at pericyclic, spectroscopy, stereo, then you can focus more on the reactions and the reaction mechanism. So that will depend individually on what kind of preparation do you have, or what kind of command do you have over these different kind of sections. So at last, I would just like to tell you that whenever you're doing a question, or whenever you are looking at a reaction or a reagent, just try and think about the regioselectivity. That is there a way that this reagent might attack a different position? Try to think about the chemoselectivity. Okay, if this is a reagent given to me, does it have some kind of chemoselectivity? Does it have preference towards certain functional groups? And then at last, the stereoselectivity. And when we are talking about cyclization reactions, you will see that most of the times in rearrangement reactions or questions in the CSR exam, there's always some kind of cyclization. So when the cyclization is taking place, again, you need to decide that, okay, if everything else is same, then if there's a possibility of formation of a 5-membered ring, or a 6-membered ring, or a 7-membered ring, or 4-membered ring, which one will be preferred and in what conditions? So if you keep these things in mind, I think you will definitely be able to do really well in the organic chemistry section of the upcoming CSIR-NET exam. So I hope you found this video helpful. If you did, please give it a big thumbs up. And if you have any queries that you want to ask me live, again, on Thursday, that is today's Monday, right? So I don't know what exactly is the date today. I think it's on 7th. Okay, Thursday, 7th July. So the class is from 9 to 11 p.m. All right. Thank you so much for watching. And if you found this helpful, please do share it with other aspirants also. That will mean a lot to me. Thank you.
Hey guys, so I'm a verified educator on Unacademy, and along with that I'm also available on the Unacademy Plus platform, where I'm taking live classes along with other educators. So in case you're interested in attending the live classes, you can subscribe to the Unacademy Plus platform using my referral code, that is SETHI, and that will give you 10% discount. Alright, and in case you're not interested in attending the live classes, you can watch the free courses that are available on the Unacademy. For that, all you need to do is go to the Unacademy website or download the Unacademy Learning app and search my name over there, that is Acidity. Once you do that, you will get the access to all the free courses that are available on the Unacademy platform. Alright.